Hello. The Department of Economics and Business has decided to make some cookies. In order to do so, they need ingredients, labor, and a small oven. They can change the number of ingredients and the number of workers, but they're stuck with this one oven. Therefore, we say that labor and ingredients are variable inputs, while the oven is a fixed input. The other day, the entire department got together for a baking party. Dr. Hassan supervised and kept track on everyone's output levels. Here are the numbers that Dr. Hassan wrote down. As you can see, Amy was able to produce 8 cookies, and Amy and Menelik together made 18 cookies. Amy, Menelik, and Tim could produce 26. Add Chuck, and they can make 32. Add Hannah, we have 36 cookies. And when Patrick, decided to bake a little bit, we only got 38 together. Now, when you look at these numbers, you can see how much each additional worker added to the production. So when we added Amy, we got 8 more cookies. You see that? And then when Menelik came along, we got 10 more. We went from 8 to 18. And when Tim, the marginal product was 8, Chuck added 6 extra cookies, Hannah added 4 extra cookies, and Patrick added only 2. We could also calculate the average product. How many cookies did we get on average when we added 1, 2, 3, 4, 5, and 6 workers? So with only 1 worker, we had 8 cookies on average. But with 2 workers, we got an average production of 9. 3, 8.67, 4, 8, 5, 7.2, and 6, 6.33. Note how we did this. We just took the number of cookies and we divided by the number of workers. 18 divided by 2, 26 divided by 3, and so forth. Now we have how much we were able to produce, and Dr. Hassan was very proud of us. But let's see, in order to work with these numbers, we need to create a production function. A production function shows how much each additional worker adds, and it shows how much in total that we're able to produce. So what I've done here is just plot all the numbers. So we have Amy was here, then Menelik, and then Tim, Chuck, Hannah, and Patrick. And we added more and more cookies. The notable thing here is that this production function is getting flatter and flatter. So it's increasing, but at a decreasing rate. That's going to be a very important thing to remember, a very important factor, and that is the law of diminishing marginal product. Diminishing marginal return or diminishing marginal product. Alright, so we have all our total product right here. We can also look at our average product and our marginal product. So what I did here was just to plot the average product and the marginal product, and you can see that in our example, the marginal product first increased a little bit. So when Amy and Menelik were working together, they were able to specialize, and therefore they both got more productive. But as soon as Tim came along, the diminishing marginal returns start kicking in, and they went down from there. The average product is just plotted. We just calculated that, and then I just plotted it on this diagram. An interesting thing here is that the average product and the marginal product intersect at the average product's highest point. So this is the maximum average product, and that's where they intersect. So when the marginal product is greater than the average product is increasing. And when marginal product is less than average product is decreasing. Okay, so here we have all the product curves. Now, in order to get all of us to work together, Dr. Hassan had to pay us money. When we add money, we can derive our cost curves. So let's do that next. Okay, so Dr. Hudson is going to have to pay us some money, and this is what he had to pay us. So each person was going to get $10 for their hard labor, and the ingredients cost 25 cents per cookie. And of course, the oven is a fixed input, and so there was a fixed cost of $20 for the oven. Now we can calculate what the total cost, the fixed cost, and the variable cost are over all these different quantities that we produce. So let's do that. And I already did it. So here's the table that shows all the costs for each additional cookie. And what we see in this table is that the fixed cost is always the same. The fixed cost never changes. It doesn't depend on the number of cookies. We always have to pay for the oven, no matter how many cookies we produce, including when we produce 0 cookies. But the variable cost will change because we have to pay both for the workers and for the ingredients. And so I calculated the ingredients here. For example, when we had 8 cookies, then 8 times a quarter is equal to $2 plus the cost of Amy, which is 10, so the total variable cost was 12. And here we'd have $20 is the cost of Amy and Menelik, and then another $4.50 because we had to pay for the ingredients that were required to produce 18 cookies. So I just calculated all the variable cost in this column right here. And then the total cost, that's just adding the fixed cost plus the variable cost, and that's 32 for 8 cookies. And when we made 18 cookies, we can see that it's 20 plus 24.5, which is $44.50. So the total cost is the cost of making all these different amounts of cookies, fixed cost plus the variable cost. Now the marginal cost. The marginal cost is really interesting, and that's a really important concept. As you know, that's related to the supply curve. So this is a very important thing. I'm just going to write how we calculate the marginal cost right here. So marginal cost, that is equal to the change in total cost divided by the change in quantity. So in order to calculate this 1.5 here, I took the change in total cost, which of course is equal to the variable cost because the fixed cost never changes. So there was 12 divided by 8, which was equal to 1.5. Now when we were doing the next one here, the change in variable cost is actually 12.5, and the change in quantity was equal to 10, and therefore 12.5 divided by 10 is equal to 1.25. So I can calculate all the different marginal costs, and you can see that first it decreases and then it increases and increases and increases, and that's another sign that we have diminishing marginal returns here. Diminishing marginal return says that the marginal product decreases, and when the marginal product decreases, the marginal cost increases. Those are totally related to each other. Alright, and I also went ahead and calculated the average fixed cost, so that's just going to be the fixed cost divided by the number of cookies. Fixed cost, so it'll be 20 divided by 18, 20 divided by 26, and you can see the average fixed cost is always decreasing, obviously, because you're spreading your fixed cost over more and more output levels. The average variable cost is very similar. You take the variable cost and you divide it by the number of cookies. And the average cost, average total cost, that's just adding up fixed cost, average fixed cost plus average variable cost makes average total cost. And I did those two. Alright, so now we have all the numbers, and what we want to do next is just plot these numbers, and you can see they're really interesting. So what we want to do is just put this one away. Maybe we'll go ahead and bring this one up here. So let me just move this to the side. Okay, so here's our plots of our marginal cost, average variable cost, and average cost. And you can see here, once again, that the marginal cost is first decreasing, and then it increases And it increases fast. And that is, again, because of diminishing marginal returns or diminishing marginal product. The average cost is first decreasing and then it increases. Average cost is again decreasing and then increasing. And note again that the marginal cost will cut the average variable cost at its minimum, and it's going to cut the average cost curve at its minimum. And that has to be true. So whenever the marginal cost is lower than the average cost is going to be decreasing. And when marginal cost is greater than average cost is going to be increasing. Alright, so these are the really important cost curves, and we're going to use these cost curves when we calculate profit. When we're trying to figure out how the firm will maximize profit, these are the curves that we're going to be using. And so the next question is basically, how many cookies should the department produce? And that answer is going to depend on what we can sell the cookies for. For example, if we were able to sell the cookies for, I don't know, say $3, so if this was the price, then what we're going to do, we're going to set marginal revenue, which is the price, the price of the last cookie, equal to the marginal cost. And then that's going to be deciding how many cookies we want to be producing. And in this example here, we can see that the department will not need me to produce any cookies, because when I produce cookies, because I can only make 2 extras, if you recall, and having me produce cookies is actually more expensive than they can sell the cookies for. So they're going to get rid of me and only the other 5. So I'm going to go home. I'm probably going to read a book or something. But before we stop here, I can also show you how we will calculate the profit. If the price was $3, we decide to produce 36 cookies, and the profit is equal to total revenue minus total cost. And what we're going to do is we're going to find this profit by comparing the price to average cost, and then we're going to calculate this little rectangle here, and that will be the profit. But more about that later. Thank you.